Hello, welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. I'm delighted to say and welcome back Robert Rogers from Mettler Toledo today. And we're going to be talking about return on investment of product inspection devices. So welcome, Robert. Nice to have you back.
Thank you very much. Glad to be here again.
Yeah, and we've just been talking. You're in Tampa, Florida.
That's correct.
Yeah, but thankfully safe and sound from the hurricane. But thinking of people who have struggled recently with that. So, on a lighter note, can you tell us where you're joining from in the sidebar? Rule from Philippines. Who else have we got? Mazuan from Malaysia. Nasos from Greece. Karasuju from KSA. You're welcome wherever you're from. I'm going to play the sponsor ads now, and then we'll be back for Robert's presentation shortly.
Food safety accidents are a real possibility these days, meaning an increased scrutiny and rigorous testing on production and other areas. From farmlands to dining tables, each stage of the entire food supply chain is challenged by product safety, quality, and effectiveness. Whether you're a grower, food packer, trader, or hold any important role in the food supply chain, HQTS can help you to ensure quality and safety from the source. Our services include product inspections, safety audits, quality management, and consulting and training. HQTS, your partner in quality.
Okay, let's get the slides up. Where are we? There we are. Okay, I'll be back for the Q&A afterwards, but for now I'll hand you over to Rob.
Perfect. Thank you very much. Appreciate it, Simon. I'm going to turn my video off here just because I'm hoping it will clear up that screen a little bit, and there may be some data in that spot down there that I don't want to hide with my beautiful face. So I hope you don't mind not seeing me, but here we go. Again, my name's Robert Rogers, Senior Advisor for Food Safety and Regulation with Mettler Toledo. Happy for you to join us here today. I wanted to talk a little bit about return on investment for product inspection solutions. And certainly when we make significant purchases in our personal lives, like buying a house or buying a car, or certainly when we're purchasing capital equipment in our business lives. We tend to assess value to the things that we spend our hard-earned money on and look to see what sort of return on investment there may possibly be. And return on investment can certainly be looked at in many, many different ways. And that's what we're going to look at in this session, really at how product inspection solutions, there are different ways to identify and understand and calculate the return on investment for these type of solutions. Let's take a look at what happens when something goes wrong, and certainly look at the cost of a recall. When we look at those sort of things, there has been some studies on that. And in that study, they found that the average cost of the recall to a food company was $10 million in direct cost. And that would be in addition to any brand damage or lost sales. And again, this is from a relatively old study now. With today's inflation, I'm sure that number is going to be a little bit higher. And these are, again, just those direct costs, which typically include notification to the regulatory bodies and obviously the supply chain and consumers, the product retrieval, all the reverse logistics involved in that, storage of those materials, destruction of unsaleable product, and of course, the additional labor and costs associated with these activities. Then there's the investigation of the root cause and hopefully a way to prevent this from occurring again. So again, the cost can be extremely high, especially when you start to bring in those indirect costs. Looking at some of those indirect costs, these could arguably be the most significant cost to the company. The litigation costs, costs from any agreed or mandated governmental oversight after the incident, certainly the lost sales, and the impact to the company's market value and brand reputation. Today's consumer cannot help but be aware of food recalls with the 24/7 media coverage and the power of social media and social networking to both spread the news and really influence the brand. Some polls show that 55% of consumers indicate that they would switch brands temporarily following a recall. 15% said that they would never purchase the recalled product again, and 21 would avoid purchasing any product made by that brand manufacturer during the recall. Well, and if you look at just preventing those things, preventing one recall, a robust product inspection solution will have an immediate multiple return on investment calculation. So there you have it. I'd like to thank you for joining, and I'll take questions. No, really, seriously, there's more, but this is certainly a big one. This is exactly what product inspection solutions are designed and implemented to do: prevent non-conforming items from reaching the consumers. But certainly, again, there's going to be other ways where we can determine a return on investment of our product and solution investments. If we look at inline checkwares, these may be the easiest product inspection device for us to identify a return on investment with. Checkwares, of course, check the weight of packages as they travel across a load cell and reject packages that are outside of the tolerance. Applications without an accurate checkware will most likely slightly overfill products to ensure that underweight products and materials don't make it to the consumer. And in doing so, they have a high level of product giveaway. And reducing this through a robust checkware system can have a very quick payback on the investment. So we look at things about weight. I mean, how many of us have actually seen or really held a gram of weight? It's really actually pretty small. And if you've ever seen or held a gram, it may be a bit tough to understand what significance a gram can have. So if you're at your desk right now or near your desk, here are some items that have the approximate weight of 1 gram. About 5 small rubber bands. That would equal about 1 gram of weight. 2 standard paper clips. These would be the most common size paper clips that you have. They're about 30 millimeters in length or so. 2 of those would equal about 1 gram. If you have your desk stapler nearby and took about 19 staples out of there, that would equal about a gram. Or if you've got a Post-it note, take 3 of those sheets of Post-it notes out, rip one of them in half, and you'll probably be close to about a gram in weight with 2.5 sticky notes. And so you can kind of see that weight may not feel like a significant amount of weight or value, but when you look at it in significance in everyday production, it can have quite a bit of an impact. Here we see a situation, for an example. Say we have a 450 gram package, the average overfill of just one gram. The production line is running at 200 packages per minute. In this example, we'll also say that the factory runs 3 shifts per day and they utilize that line for, say, 20 hours a day. A 1 gram per package saving will equal 200 grams per minute, 12 kilograms per hour, 240 kilograms per day, and 55.2 tons a year in product savings. Now, what's even more impressive is that the inventory savings can now be used to produce an additional 122,000 plus packages per year. And of course, we're going to get the results of that revenue and the margins and profits that are associated with that extra packaging. So really limiting overfill can have a really quick impact on that return on investment. If you look at how much that gram is worth, we can see even more cost savings there. Say we have that 450 gram package, the average overfill of just that 1 gram, and the production line again is running 200 packages per minute. The product cost itself is 2 cents per gram. And again, we'll say in this example, we're running 3 shifts per day and we're utilizing the line for about 20 hours. Obviously, through the calculations, the per package saving is 2 cents because we're saving 1 gram and the cost it's 2 cents per gram. The savings per minute equals about $4, turns into about $240 per hour, $4,800 per day. And if the factory is open and operational for about 230 days per year, then that 1 gram saving adds up to a staggering $1,100,000 plus per year. And I mean, did someone say ROI, return on investment? I mean, it's pretty clear that that can be a relatively quick return on investment simply by tightening up the tolerances on our product giveaway. This slide might look a little bit jumbled here, but I apologize for that. Some of the animations didn't run through and I didn't necessarily consider it on this slide. But I've been in the industry for about 25 years myself, and I've visited equipment that's still in operation that I personally installed many, many years ago. And as with most things, they age or as they age, the risk of breakdown increases. I know as I've gotten older, my breakdown has increased as quite a bit extensively. It takes me longer to heal. With breakdown certainly comes downtime, and downtime can be extremely costly. Here we see a chart showing the typical failure rate of a metal detector, where the average age listed in years and the percentage of the chance of breakdown. As you would expect, the older the device, the more chance of breakdown due to the failure in the device. And again, the chart is a little bit jumbled here, and I apologize, but this particular case, we had 10 systems in the facility that were less than 15 years of age. 4 of those systems were critical control points. 8 of the detectors are between 15 and 20 years old, 4 that are between 20 and 25 years old, and 4 metal detectors that are over 25 years old, with 2 of those being critical control points in this case. Legacy systems that are over 25 years old may no longer be repairable due to electronics no longer being available. And those 20 to 25 years of age it may not be advisable for repair, and they may soon lose their electronic availabilities and they may be better to replace than to repair. With those things considered, we've calculated the number of potential breakdowns along with the downtime for repair. And from that figure, the cost of downtime per hour, we've calculated the loss of production hours, and you can quickly see here on this chart that cost again adds up very quickly. So when we look at return on investment from capital equipment for, say, like a metal detector in this case, we need to assess the age of the system, as long as the potential breakdowns and what sort of costs we may incur through downtime. Those calculations can quickly add up to a good return on investment story for either replacing older equipment or potentially, whether or not we want to repair or replace those equipments. So we just saw that production downtime has a direct negative impact on the bottom line. Really, any stoppage results in lost production and revenue. Retailers and food safety standards and regulations require routine performance monitoring of critical control or preventive control devices, such as metal detectors and X-ray systems alike. This activity often results in downtime. So one way to improve a return on investment would be to implement a reduced testing capability. Systems with intelligent capabilities to continuously check the performance of the metal detector to a level of certainty where the frequency of the routine performance monitoring can be significantly reduced. Of course, this would be subject to any quarantine guidelines or limitations in that regard. But in this example, we have 120 products per minute. There are 12 tests a day, so maybe one test every hour on a 12-hour shift. And you can see the other details here. And again, that $15 an hour, that may need some adjusting in today's market, but okay, we'll go with that. It looks like we have 15 metal detectors. And in this facility, based on this information, we can see here, we're currently producing 31 million plus thousand packages annually per line, or 466 million plus packages per year out of the entire factory. Reduce the testing frequency to the start of the shift, the middle of the shift, and the end of the shift. Certainly makes sense and is safe to understand the operation and capability of the system. But with that, the added confidence of a reduced testing mode and the improvement in that can be very impactful. 9,720,000 more packages produced and a labor cost savings recognized as well, all contributing to a more rapid return on investment for that particular product line. Another area to look at. I'm always quite often asked, how do you properly set up an inspection device? And unusually, I think, my answer is never to achieve a particular result or spec. It's always set the system to successfully inspect production with the goal of minimizing or hopefully completely eliminating the potential for a false reject. False rejects are really your worst enemy regarding inefficiencies and waste. It's good product that's now in the reject bin that we're simply going to throw away, or we're going to have to do some reworking in order to reintroduce that product into the production line. Either way, it shouldn't have happened because it's a good product that is now in that reject bin. Improvement in this area can have a direct impact to the bottom line and is a great place to look for return on investment. In this example, we have 10,000 products per hour and say about 5 false rejects. You can see the revenue potential or the revenue per product and the other production data. All this calculates and works out to about 10,000 products wasted due to false rejects annually. Decreasing the false reject rate through proper setup or through improved technology, say down to 200 false rejects per year, allows for a greater number of successful products, resulting in revenue gains. In this case, 9,800 more products were produced, leading to those increased revenue gains. In addition, less false rejects will result in less labor to deal with those false rejects, and that can have a major financial payback as well. In the case of higher false rejects, consider the additional resources and labor to investigate and resolve the issue. Additional cost savings can be found there. And when added with the savings calculated previously, a reduction in false rejects can have a significant amount of potential return on investment. Label errors, again, a little bit of another jumbled slide. I apologize for that. But label errors are one of the most frequent reasons for product recalls. Even a small recall can carry significant costs in both time and resources needed to both react and resolve the issue. Manual checking of labels and random sample checking of labels should catch errors in theory. However, by the time the error is discovered, there may be hundreds or thousands of products created with the wrong label. And even if these products don't make it to the consumer, there are significant costs involved in rework and scrap. Clearly, as we get further down the supply chain and the issue is discovered there, the higher the cost is going to be. And we've seen the potential financial impact of a recall and what that can have to a business. So catching the error earlier and preventing these issues, this is where the value of an inline automated vision inspection solution can be easily recognized. In this example, and again, I apologize for the jumbled screen there, but we can see some of the numbers on the sidebar there. The example cost of the vision inspection solution is valued at $135,000. Factor in the cost of the errors from manual inspection over the course of the year, and you find that less than 1.5 year return on investment for this particular vision solution in this particular case. So these are some of the factors that we can look at from a vision inspection perspective as well. Clearly, product quality and safety should be a focus at every stage of the process, from raw material receipt to final packaging, not only to protect the consumers, but also to reduce the recall risks and overall waste, create less rework, and impact a positive return on investment. Historically, we've seen product inspection devices like metal detectors, checkwares, X-ray inspection, vision inspection systems located near or at the end of a process, typically after the product is in the final packaging. And of course, this makes sense when you think about most inspections. As an example, for inspecting for the presence of proper expiration date or confirming compliance to proper weight declarations, the final step of the process makes sense. Certainly, inspecting for metal detection and X-ray inspection at this point makes sense as well. But let's look at things like identifying the root cause and identifying non-conforming items at the end of the line will result in having to look back through the entire value chain or the entire production line, because it could have been caused during transportation, it could have been caused during delivery, it could have been caused during the production process itself. Makes it really difficult to identify the true source, and so proper corrective and preventive measures can be implemented. And with sustainability initiatives at the top of most business priorities today, think of all the waste involved at discovering at the end of the line, all the raw materials used to manufacture the product, waste, all the energy, time, and money invested to produce the product, waste, all the packaging material, waste. It's really difficult to discover return on investment with these sort of situations. So inspecting throughout the process and will not only remove the non-conforming items from the process as early as possible and reduce the risk of recalls, but will also result in improved efficiencies and waste reductive initiatives for a more rapid return on investment. So that's about all I have today. I want to thank you for the opportunity to meet and discuss. I hope I've identified some ways that we can increase or identify return on investment for product inspection solutions. These return on investment calculators can all be found along with much more information by visiting our website, mt.com. And again, I'd like to thank you for attending, and I'm happy to take some questions now.
Thanks, Rob. Appreciate it. Okie dokie. Questions. Feel free to put them in the sidebar. I've thus far haven't seen any, but now's your time. Rob is an absolute world expert on all things metal detection, X-ray inspection, and more. So while we've got him here, let's make the most of it. Any questions for Rob?
Whenever this happens, you just know I did such a fantastic job of explaining everything that I've just answered everybody's questions along the whole way. So it's a pat on my back.
That's it. I mean, previously we've run potentially, I think, 30 minutes over and still not answered all the questions previously. So maybe you have answered all the questions. So anyway, there is a question from Guilia. Issue of glass detection in glass bottling production. What is the best technology?
Yeah, there are application for glass and glass type inspections through X-ray inspection. It's one of the more challenging inspections to perform because, of course, the foreign material, in this case, a chip of the glass, is really as well part of the packaging. So when you set up an inspection system, again, I always say to set it up to successfully inspect the product, part of which would be to successfully allow the glass packaging to pass through the X-ray machine. And now you're trying to tell it, well, also that part of the packaging, if it happens to be inside of the package, is now a contamination. So it is challenging, but there are certainly successful applications for glass and glass X-ray inspection capabilities, and X-ray would be one of the best technologies. You can get some visual inspections, maybe through a vision system, but historically, I think for that sort of concern, X-rays are probably the dominant source for that.
Thanks, Rob. Question from Agnetha. The vision inspection systems mentioned, is that part of a more comprehensive traceability system and/or warehouse stock system?
Typically, our vision system solutions are more so to inspect issues with the labeling or the printing that is being performed on a package. There are some solutions along vision when we talk terms of traceability. Those are more so today focused in the pharmaceutical area, where we're doing serialization type activities of a pharmaceutical component and traceability of that as it's going from a blister pack into a carton, into a case, onto a pallet, that sort of aggregation of that serialized data. As far as the food and beverage industry, certainly we're starting to see and hear things around traceability in the same sense as we have heard historically in the pharmaceutical space. Certainly the Food and Drug Administration is coming out with new rules in November regarding the traceability of certain food products that they've identified. So I believe that we'll start to see vision solutions in the food space be more adapted towards traceability type aggregation solutions that we see in the pharmaceutical space. And I imagine that will be coming very, very soon.
Okay, thank you. Question from Johnston. Do you know of a check weigher for cans at 400 cans per minute?
Yeah, I mean, check weighing speeds have certainly the capability of increased speed without the loss of accuracy has always been the challenge. And new, what we call in our devices, we have new flash cells that have kind of answered some of those challenges that have historically been in place with speed and accuracy. Um, those are always best. There's a lot of things that is defined in determining what is the best solution for the application, but that is certainly an application that seems feasible and within the realm of possibilities.
Okay, thanks, Rob. Okay, question from Carlito. What is the best metal detector for bread and pastries production?
When you talk about metal detections, the concern or question that I have is always in regard to the product condition. Basically, any standard detector conveyorized as the bread travels through there will be fine. In bread and pastry applications, if we're doing it pre-packaged or post-packaged, there's questions that'll arrive during those concerns as far as the packaging material. As an example, we oftentimes see a wire metal bread tie on a loaf of bread. So obviously that traveling through a metal detector might have some concerns as far as what the inspection capabilities would be. If we could do that prior to the packaging, obviously sensitivities would be better. Conditions of the product again would have a factor, whether the product is warm and moist at the point of inspection. There's going to be more product signal with those conditions in the product, and therefore we would have to reduce the sensitivities of the detector just to again successfully inspect that product. So there's a lot of questions in identifying what would truly be the best solution for you. We do see metal detection in that application quite frequently, so it's not an unfamiliar application for a metal detection inspection for sure.
Okay, a question from Mohammed. As a regulator, we are using inspection tools such as thermometer, lux meter, pH meter X. What do you recommend more effective inspection tools for food regulators?
Well, I mean, just the same as a thermometer or a pH meter or anything in those regards are measuring devices. The measuring type devices that our product inspection division provides, I consider a metal detector and an X-ray system, and obviously a checkware measuring devices. It's just what are they measuring, right? Obviously, a thermometer is measuring the temperature. Well, a metal detector is measuring the amount of signal that is in a particular product. And if that signal is over a particular point, there is a concern that it could potentially be metal, and therefore it gets rejected. So those sort of devices, just like a thermometer, need to be calibrated occasionally to ensure that they are reading the proper measurement. So just like a thermometer, a metal detector, a checkware, a vision system, an X-ray system really should be calibrated. Or if you don't want to use the term calibration because of the device may not be apropos to that, the performance needs to be verified on that system. So we recommend that those are annual inspections that are performed on those such devices. But so I'm not really sure if that answers that particular question. But inspection tools, as far as product inspection devices that we see in the space, are again the solutions that Mettler-Toledo would provide: metal detectors, X-ray, vision, inspection, and check weighing devices.
Okay. Question from Vasana. Using X-ray for a variety of dense product with different sizes, what's the best way to set up the X-ray?
Well, that's exactly what an X-ray is working on, right? It's working on a density principle where it's looking for differences within the object of different densities. When we have a very homogeneous product, i.e., it doesn't have variations in density, like a block of cheese, very easy to set up in an X-ray because a contrast looking at density in a product that is very homogeneous and has an even density, we'd be able to very distinctly see those differences. In an object that has varying densities in the product inherently, let's say, oh gosh, what would be a good example? A gallon of ice cream, but this ice cream has cookie crisps in it. So the cookies chunked up, cookies and cream ice cream. So it's got cookie chunks in the ice cream. Those chunks within the ice cream are obviously going to be different density points within the inspection of that through an X-ray device. So what we would have to do is during the setup of that product or the teaching of the product to the X-ray machine, we're basically letting the X-ray machine know what good product looks like. And once we've set it up to accept those good products, then we're going to look for differences above and beyond that. Now, that's being said, that application where we have varying densities in a particular product, like that ice cream example, we would be able to set up the X-ray to successfully inspect that. Would we get as good sensitivities in that particular product as we would get in a plain jug of ice cream that didn't have any density variations in it? There may be a slight decrease in the overall capability as to what we're able to detect in those different situations. But that's why I'm always a huge advocate of saying, set it up to successfully run production. Then challenge the inspection device to see what it's able to read or see or identify at that point. And that way you'll know, with minimal false rejects, a proper setup of the inspection device, what the true capabilities will be of that device, as opposed to setting it up to see a spec and then just living with the aggravation of false rejects or waste involved in false rejects. It would be much more better to have a true understanding of what your capabilities are and then make informed decisions off of that than it would be to think you're detecting something just because you set it up to detect it.
Okay, thanks. A question from Barak. What is the effective technology for the detection of plastic and fingernails in packed time?
Yeah, good luck. I don't believe that there would be a good technology today to successfully identify that application. Organic materials like fingernails and hair and insects and things of that nature are certainly difficult for an X-ray to see because most products have an organic characteristic to them, and we've set the system up to ignore it as we've set it up to successfully run product. So those are challenging materials to identify in really any technology today. You may see some capabilities in vision. It's going to be very product specific as to whether it would be able to identify those if there was color contrast differences between the materials. Things of that nature will all play a big factor. Most likely that packed time through an X-ray machine, certainly, unless it's a super dense plastic or an X-ray detectable plastic, you're probably not going to find it. And fingernails, I'm not certain of anything that would be able to identify that in today's industrial market at speed, at production.
Okay, question from Charles. How would we disseminate this microscopic waste in terms of material and dollars to small-scale production systems?
I mean, it depends on what you mean by microscopic waste. I'm not certain. I mean, again, I've seen some product recalls where there's thousands and hundreds of thousands of packages that are being recalled, and that doesn't seem microscopic as far as waste to me. If that were an impact, I'm not really sure where that is. Yes, some of the things that I've identified here, are they major financial impacts and returns on investments over the course of a small period of time? No. But over the course of the life of a metal detector, some of them, again, being out there 25 plus years, still in operation, those costs can certainly add up. And when you look at things for trying to identify ways to look at return on investment, I think those microscopic ways, if you will, certainly over the course do add up to potentially significant impacts.
Question from Carly. So, again, detecting hairs in breads and pastries production.
Yeah. Not that I would be familiar with, and certainly the inspection devices that we have, I wouldn't I wouldn't say have those sort of capabilities at all.
We'll move on. Christina, can you explain a bit why low pH foods are so difficult to set up with a metal detector?
Yeah, I mean, a metal detector works on a conductivity principle. So anything that affects the conductive nature of a product can have an effect on it. So we do see typically things with high moisture percentage, high acidity, high temperature. Again, you take a frozen hamburger patty, you can run it through a metal detector and it will barely produce any signal from the patty itself. Take that same exact hamburger patty, let it begin to thaw out to where the hamburger is now soft, moist. The moisture percentage has come back, temperature has come back. That hamburger patty will now set off the detector itself, just like a piece of metal would. So that's why I always am a huge proponent, and you hear it from me all the time. You set up a inspection device to successfully run production. Whatever variations in production that are acceptable as good quality, safe product, we want to set the inspection device up to accept those variabilities as well, because you consider that good, safe, quality product. So should the inspection device. And in doing so, oftentimes we're needing to maybe desensitize the overall capability of the device to successfully run that product. But that would be my solution. Set it up to successfully inspect the product within your acceptable variability, and then challenge the inspection device to understand what its true capabilities are. And if its true capabilities do not satisfy the need, at least we're informed and we have that information. And now we can look, well, is there another point in the production environment where we can detect down to what we need to detect in your application? And then just do a risk assessment from that point in the production to the point in production where you're currently inspecting, identify what those risks are, and make sure that that secondary inspection is able to control those risks that we identified in that space.
Okay, that's a duplicate. Question from Agnetha. Let me just grab it. Sorry. Right. What is the lowest detection limit of available metal detectors in the market now? Usually we want no metal critical limit equals 0, but no detector can guarantee this today as far as I know.
Yeah, I mean, you're always going to be limited on the capabilities of the particular inspection device, and that can be many different factors. If you were just blind, what is the lowest detection limit of available metal detectors? Well, we have pharmaceutical detectors, and they are able to detect down to a 0.3 millimeter piece of stainless steel. That is a speck. It's smaller than a grain of salt, is how small of a piece of metal. Now, that's in a pharmaceutical detector. The opening in that pharmaceutical detector, which has an impact on sensitivity, the larger we go in the opening, the less sensitive a metal detector is. A pharmaceutical opening is only about that big. It's a very small, maybe a 3-inch by a 2-inch aperture. Little tablets and pills are having to travel through there. Very sensitive. Now, obviously, through a detector that's only that big, I can't get a case of hamburgers through that. So I have to have a detector that's big enough to run the product that I'm trying to inspect. And in that case, there's going to immediately is going to have an effect on what its detection capabilities is going to be. So it all depends on the physical size of the detector and then the conditions of the product, again, as far as how high of a sensitivity the product allows me to set the sensitivity. Certainly every metal detector out there, regardless of its size, I can operate it at maximum sensitivity and get the most out of the detector, but that may falsely reject 100% of my product. And in that case, it's, I'm not winning that game. That's not a good setup. I'm going to throw away 100% of my product that I manufacture. Nobody's winning that game. So you'd set it up to successfully run the production and understand what the capability is going to be. So again, it's not really what the detector can do. It's what the product allows us to do, both in the application, the size of the detectors, the opening sizes, and the product conditions as far as sensitivity levels, whether that's an X-ray inspection, a metal detector, a checkware, a vision system. We have to set those systems to successfully run production. And sometimes those production characteristics limit the capabilities of the inspection device.
Okay. Guilia, if a supplier does not have metal detector, X-ray detector, or checkweigher, is this a red flag not to use them, or are there exceptions they would not use, where they would not use these tools, not be expected to use these tools?
Certainly, when we look at product inspection devices like metal detectors, checkwares, X-ray, vision systems, whatever the case may be, there are other ways to achieve the same results, right? Maybe instead of having metal detectors, I have filtering and sifting and screening and magnets and X-ray instead of a metal detector. Well, I'm protecting against physical contamination or whatever risks I'm trying to protect against. For check weighing, instead of having an inline checkweigher, maybe they do sample weighing where they're spot pulling off a certain number of items every shift, taking those to a static scale and weighing. So there's ways to accomplish the same thing out of an inline inspection device. So I wouldn't necessarily say if they don't have them, they're a bad actor and I can't trust them and those sort of things. They may have other programs and procedures in place that allow them to achieve the same sort of results. Now, if they didn't have these sort of things, I would be considering, maybe are they the best one for me, number one, because there's certainly going to be, if they have inline inspections rather than offline inspections, there's going to be more, the line's going to be more efficient. For check weighing as an example, I'm inspecting 100% of the items weights. I'm not only doing every 100th package weight and risk that maybe I'm missing them. So I think there's less of a risk in implementing some of these solutions, but I would not just necessarily say if they don't have them, they're a bad actor and I don't want to deal with them. Understand what they're doing and how they're doing it and why they're doing it certain ways. And it may, identify that, hey, they're doing what they should be, where they should be, how they should be. It's just that's their limitation because of resources or size or scope or whatever. But no, I wouldn't say if they don't have them, they're bad. I would say that maybe if they don't have them, you do a little bit deeper dive to understand how they're dealing with those concerns that those inspection devices solve, and see what those answers are. And that might highlight and answer questions better for you.
Sure. Question from David. Can you explain how humidity may affect metal detectors?
Yeah, and again, we don't see much environmental issues, outside environmental issues affecting the performance of the detector itself. The devices are designed and built to withstand some extreme temperature variations, both hot and cold, some extreme washdown type environments. So the systems are really designed around those things. Where we can see those things affect a metal detector is really when temperature, humidity, those sort of things affect the product. So an example would be I'm in a frozen food product in the winter time. Everything works great because the plant is nice and cool. The product's frozen out of the freezer. Everything's great. In the summertime, because it's more hot or humid in the plant environment, product that's sitting outside of my freezer now begins to thaw more rapidly during the summer than it does in the wintertime. Another issue we tend to have in the wintertime can be around static charge and static discharge of plastics rubbing against each other. That can be a problem more so in the wintertime because the air is drier. So it's more prone to static environments versus the summertime when it's more humid and hot and the air is more damp. So static availability is less. So variations in the environment can affect the systems in those senses, but primarily what we look at is how those environments affect the conditions of the product, and then how those varying conditions in the product itself affect the inspection device.
Okay, no shortage of questions, Robert. As expected, bit dry at first, but yeah, Nature, presently we are using a mechanical sorter to detect stones in dried peas and beans, which has not been very effective. I guess we need to invest in an X-ray system.
Yeah, and as with anybody that is looking to make investments in any of the product inspection solutions, utilize, we offer free product testing. So you can send some samples into our laboratory. We'll run them through some inspection devices and provide a report on the detection capabilities. When we talk about stones is one of those materials that, yes, could be identified in an X-ray. Absolutely, 100%. We see those applications all the time. But stone, when we talk about stone, there are thousands, if not hundreds of thousands, of different types of stone and different mineral contents within those different types of stone. So there can be differences of detectability. When we say, can it detect stone? Well, pumice rock versus granite, there's a lot of density difference between those two materials. Sandstone here in Florida versus sandstone in Colorado, minerally, there's a lot of different characteristics there. So when we look for those sort of applications where it's not just to say, hey, we're trying to detect 1 millimeter stainless steel, it's easy to find a stainless steel material, and that stainless steel material is probably going to be the same everywhere we go. That stone material, we want to be a little bit more specific, particularly if you have some examples of contamination concerns of those materials. Send that along with the product and say, hey, can we identify stone A, B, C, D, E, F, G, whatever in that material? And then that will give you a more realistic understanding of what that capability is, as opposed to just saying, yes, it detects stone. Will X-rays detect stone? Yes, absolutely. And in most applications, they will do a fairly fine job of detecting stone. But that stone and what we classify as stone, we want to be sure that we're saying the right things. That it's the stone you're trying to identify that it's able to detect, or at least you have a fair understanding of what stones we can and what stones we can't see.
Okay, thanks. Julio, would you recommend an effective filter after the inline metal detector? If not, why?
Well, I mean, I guess that depends on what point in the process, what sort of product we're looking at, those sort of things. Um, uh, I like to see, again, if it's the last point in the production line where we're doing the inspection, I don't know that I would necessarily have another filter that the product goes through after that without a post inspection of that filter. Because, of course, the filter could break down and become a contamination source. Filters after a detector that's more, upstream in the production. Sure. Again, if there's going to be an inspection device after that filter to ensure that that filter, or some sort of way to make sure that that filter isn't breaking down and becoming contamination itself. Metal detectors, x-ray systems, checkwares, vision systems, none of these devices are problem elimination devices. These devices are not getting rid of your problem, right? These devices are notifying you when all the other things that you did to try to get rid of your problems have failed you. And there's a non-conforming item that is passing through the inspection device, whatever that may be. So it's just notifying you that there is a problem. It's not preventing the problem. It's not going to eliminate the problem. It's just saying that there is a problem. It's really the processes and the procedures that you have in place, your food safety programs, as to what you do when these devices identify a problem. What you do is going to make the biggest difference. If that's stopping production, if that's recalling the product up to the last successful test, if that's quarantining product, that's re-inspecting product. What you do, your actions in your facility and built around your food safety plan, is what has the greatest impact. My device just tells you that there was a problem.
Yeah, for sure. Gene, how do you validate a magnet?
Validation of a magnet, it can be a couple of different things. Certainly you would do pull strength tests on the magnet, and you would do that periodically. In some cases, I think some food standards or food programs mandate the length of time when that's done. I think most of the time it's an annual pull test validation of the detector to make sure that it's still, in fact, remaining strong enough to do its task. As far as validation, I look at it in a few different ways. Validating a magnet, number one, the pull strength test. But what is that magnet being used for? If that magnet is then being used to pull out magnetic metal in a flow through, as the product flows through that magnet, as a dry product or a wet product or whatever the case may be, I would actually validate that it's capable of pulling out what you think it should be pulling out. Again, run some tests, some validation studies where we've induced the contamination and validate that, yes, the magnet did in fact pull that out and separate that material from there. I'm a huge advocate of multiple protections, particularly when it comes to foreign material. Use magnets, use sifts, use metal detection, use x-ray inspection devices, use all of those in conjunction with one another to get the best possibility of removing contamination. But understand that, again, none of these devices are elimination devices. They're just notifying you that there's a problem. When you open up the magnet and you see there's metal on it, you can understand that there's metal in your product. Go back to your suppliers, get them to get metal detectors or x-ray inspections so that they're not supplying you with products with metal in them. My goal of installing any of my devices on a production line is that it never rejects. It never rejects one product, because that means 100% of your products are good, safe, quality products. That should be the goal. If we have activity at one of my systems, there is a problem that needs to be resolved. And that problem is typically further backstream throughout the production line, whether it's within our building or in our supply chain. It's identified an issue. that we should try to resolve and get rid of. To have a goal that my device never goes off in production, that 100% of the products we produce are making out to the consumer and they're good, safe, quality products. That seems like a pretty efficient, sustainable type scenario to me. And I think those are big things and big goals in companies today.
Okay, I think we've made it to the last one, Rob. Rajveer, is it okay to set a metal detector at the same sensitivity for multiple products? For example, bread, various weights, 600 to 900 grams, and grain.
Yeah, I mean, it's possible. I could, in fact, turn the sensitivity of a metal detector all the way down to 0. So you could run a lot of stuff through it. What effect does that have on what it's able to detect? So that's always the thing. Can you set up multiple products under one setting? Yes. Will that affect your overall what you're trying to achieve as far as your goal of having a metal detector, in this case, installed at that point? If you're trying to achieve a particular size of contamination detection capability, then those multiple products under one product setting may limit the ability to do that. If I basically a metal detector has a sensitivity threshold window. If I have the sensitivity set very, very tightly, any kind of product deviation gets outside of that window. If I open up that window, that allows more product variability to occur before a potential false detect, if you will. So when we're running multiple products, what I'm doing is that I'm opening up that window relatively widely to allow all those product variations to fit within that inspection window. That, of course, as I'm opening up that window, is making that detector less and less and less sensitive. So if that affects your overall performance, then no, you might want to have a product for every single product that you have, a product setting, so you can have a very narrow window and extremely good detection sensitivities on that particular product. And then on product B, that's another setup that has very, very good detection capabilities for product number B. If that's a hassle or it's inefficient or you don't have the capacity for staff to set up the detector and operate it and you have to run all your products, can you do that? Yes. What's going to be compromised most likely is the detection capability. If that detection capability is satisfactory within that, then that's probably the easiest way to operate that system. You have low false rejects. You don't have anybody's setting up a product incorrectly within the system, and it's achieving what you want to achieve. It all depends on what the end result is. Is it possible? Yes, but you would want to validate it and verify what those capabilities are and whether that still fits into your safety guidelines that you're trying to achieve.
Okay, this is the final question from Ursula. If we have magnets and metal detector after, we can say that magnets are validated because the metal detector doesn't detect anything.
Again, I don't say that anything's validated ever. I validate things, right? And that's running a series of tests and challenges to prove out the theory of what we think is happening. So I don't say it's validated just simply because of a positioning of one device over another and what I see occurring from that. I want to challenge it and truly challenge it to understand what those limitations are more so, but also what those capabilities are to validate those capabilities. And it shouldn't just be, unfortunately, I think we would be better off if regulators and standard owners specifically stated what they wanted out of a validation. Because in all actuality, somebody could just run one piece of product through a metal detector and say it detected it and say, okay, I validated, I ran it, it detected it, boom, done. But how confident are you in that validation? You only ran it once. If you ran it a second time and it didn't detect it, well, now you're at a 50% chance that it's not going to work correctly. Is that a good enough validation for you to operate your entire production run on and put the risk of your consumers at? I don't think so. So that validation should be a diligent, multiple runs of that test and challenge to ensure the system is capable of doing what we think it's doing, to truly validate that capability. That's that. So I wouldn't say just simply having it in one position or another. Validate it. Run some metal through the metal detector and see if the magnet catches it, or vice versa. Let some contamination go through one of the devices and make sure the other one catches it correctly. That would be challenging it, and testing it is a true sense of validation, rather than just, I wouldn't say that because I've got it there, it's validated. I hope that answers it.
Yeah, perfect, brilliant. We've run slightly over. Lots of questions, amazing. Thanks very much for your time today, Robert. I know it's not easy with the hurricane and everything in Florida, and you're personally affected. So do appreciate you taking the time out, and I hope everything works out okay. And try and have a nice weekend, Rob.
Yeah, no problem. I appreciate it. Yeah, we were safe here. I do have some family down in South Florida that we're gonna load up and take some supplies down to tomorrow. So we're gonna do our best to help out down there as best as we can. But I appreciate you having me here today. Always great to spend time with you and your group here. Always very interactive. I appreciate the audience for attending, and I love seeing all the places from all over the world of people joining in here. So great community you have here, and always happy to help and do whatever I can.
Thanks very much, Rob. Cheers, mate. Thank you.
Appreciate you. Take care.
Okie dokie. We will follow up shortly in an hour or so with the recording slides and certificate. I haven't loaded the certificate today. I forgot. So we'll follow up in an email shortly. Recording, slides, certificate, so you'll get everything. Okie doke. Right. So thanks for joining, and we'll see you on the next one. Have a lovely weekend. Happy Friday.